You are watching video on SEE class 10 subject science. In this video series we are going to study chapters of physics, chemistry, biology, astronomy and geology. This video deals with physics chapter 4 and this is part 8 of the chapter. In this part we are going to study topics mass and weight and free fall and weightlessness. These are last topics of the chapter. Coming to the topic mass. Mass is the amount of matter contained in a body. Amount of matter present in the body is called its mass. Supposing you have 1 kg rice here, how much rice matter present in it, that is its mass. Okay, so mass is, you can say it this way also, mass of total number of atoms. Okay, any substance, any body is made up of atoms, so how much matter is present in total number of atoms, that is mass. Okay, mass remains same all the time. If you measure this 1 kg rice on the moon, then number of rice particles present in this 1 kg rice will be same as on the earth. Means if you bring it back to the earth and if you measure this 1 kg rice, then number of rice particles will remain same in it. That is why mass does not change. Okay, mass remains constant all the time. So mass is measured by pan balance, physical balance or beam balance. Here pan balance is shown. So in this pan balance there are two pans on two sides. On one pan 1 kg weight is kept, and on the other pan, supposing you are measuring mass of sugar. Okay, you will start adding sugar here. You will go on adding until these two pans become equal and balanced. No? So when these two pans become balanced, equal, this beam becomes straight, then at this time this is called 1 kg sugar. Okay, so the substance measured this way is mass, because you see in this case gravity acting on these two pans, these two same. Okay, same amount of gravity is acting on these two pans, and the same gravity in these two sides cancel each other, equal. Okay, cancel each other. That is why remaining substance on the pan is mass. That is why we call it kg, 1 kg sugar. Okay, that is mass. In our day-to-day life we call it weight, but that is incorrect actually. That is mass. Okay, because we call it 1 kg rice, 1 kg sugar. Okay, yes, 5 kgs potatoes, etc. So this is mass. Now the next topic is weight. Okay, attraction force of the earth on a body is called weight, or how much gravity is acting on a body, that is the measurement of weight. Okay, pulling force, gravity means pulling force, and the weight is measured by spring balance. This is the picture of a spring balance. So supposing a packet of sand is hanging from this spring balance. Now the measurement taken this way is weight, because this packet of sand is being acted upon by gravity from downward. Okay, so W equal to mg, weight equal to mass into g, acceleration due to gravity. So this way m into g gives calculation of weight in this case. Okay, so spring balance is used to measure weight. Now we'll see the differences between mass and weight. And mass and weight is a small topic, and this is an easy topic because you have been doing this since a small class. Okay, now we'll do this quickly. Mass is the amount of matter contained in a body, whereas force is with which a body is attracted towards the center of the planet or the satellite, or the pulling force of the planet or the satellite on a body. Mass, its value is same everywhere in the universe, whereas weight differs from place to place. Okay, from one planet to another planet, one satellite to another satellite, etc. Now mass is a scalar quantity. It has only magnitude, no direction. Weight is a vector quantity. It has direction as well as magnitude. Mass is measured in kilogram and weight is measured in Newton. SI unit is Newton. Mass is measured by using physical balance, beam balance or pan balance, whereas weight is measured by using spring balance. So these are the differences between mass and weight. Now we are going to see the next topic, that is free fall and weightlessness. Now you see free fall and weightlessness. Here are pictures on two sides, two pictures. Okay, two cases. So here in this case you can see leaves are falling down slowly. okay, and I have written here not free fall. On the other side, a stone, heavy substance like stone is falling straight down, okay, so this is written free fall. Okay, when a heavy object falls straight down without any disturbance in the middle, not even air resistance. Resistance means disturbance, blockage, okay, so not even air resistance, falling freely, this is called free fall. Okay, so how do you define free fall? When a body is falling freely towards the center of the earth under the influence of gravitational pull of the earth only, the motion of the body is called free fall. Or you can define it this way also, when a body is falling freely under the influence of gravity alone, the motion of the body is called free fall. When a body is falling freely under the influence of gravity alone, it is called free fall, right? In free fall condition, there is no resistance, okay, blocks in the middle, disturbance in the middle, falling freely, right? Not even air resistance. Whereas in this case, upward air resistance is, making these leaves fall down slowly, okay, so the upward air force acting on the surface, large surface of this leaf, okay, is almost equal to the weight of the leaf. That is why this leaf is falling down slowly. Whereas in this case, upward air resistance is acting on the surface of the stone also, okay, but the surface area of the stone is very small. That means a small upward air resistance is acting on the surface, okay, and the force of upward air resistance, weight of upward air resistance is very much smaller than the weight of the stone. Weight of the stone is much more greater than upward air resistance. Stone is falling down, upward air resistance is pushing upward, okay, so weight of the stone is much more greater than upward air resistance. That is why upward air resistance is negligible, very very small, uncountable. That is why this stone is falling down freely without any disturbance in the middle, and this case is called free fall, okay, free fall. Now you see, in the condition of free fall, we say that the body is weightless. When a body is in the free fall condition, the body is weightless. It does not have weight. Its weight is zero. Okay, that is weightlessness condition. So the body is weightless in free fall condition. We say this one. Okay. Now this is the picture of rotating Ferris wheel. Okay. You must have taken ride of this one, right? So you see, when you are going up, you feel very good, okay, after reaching at this point and falling down, you feel very strange acute sensation in the body, okay. You have seen people shouting, screaming, okay, while falling down. At this time a strange acute sensation happens in the body, and that is actually weightlessness, okay, that is actually weightlessness. We do not feel the weight of our own body in free fall condition, right? So how do you define weightlessness? Weightlessness is the state of the body in which it feels that the body is not influenced by any force, okay. We feel that no force is acting on our body, not even gravity. Gravity is not acting on our body. At this time we don't feel our weight. That is called weightlessness, okay. So you see, every time here on the earth we can feel our body weight, because every time we are acted upon by gravity, gravity is pulling our body down. That is why we feel our weight in our body, right? But if you are in free fall condition, what happens? You do not feel the weight of your body, and that condition is weightless condition, okay. Now you understood that the body becomes weightless in free fall condition, okay. So there are few more other conditions when a body becomes weightless, okay. What are those conditions? We are going to see, okay. Now see, these are the few more conditions. Number free fall condition you understood. Number 2, when a body is at the center of the earth, at the center of the earth, W mass G equal to 0, G equal to acceleration due to gravity is 0, and in the space at null point, there is no gravitational force. In the space, at some points in the space where gravitational force cancel each other and there is no gravitational force. So at this point the value of G becomes 0. Okay, so whenever value of G becomes 0, it is, weight is 0. Okay, W equal to mg and mass remains same. If G is 0, then weight is 0, right? Weight is 0 at the center of the earth and at the null point in the space. And there is one more condition in the artificial satellite orbiting around a heavenly body, because the artificial satellite is in free fall condition. Orbiting artificial satellite is in free fall condition. So whenever body is in free fall condition, it is weightless. So far we have been studying that the body is weightless in free fall condition. How this is, okay, how this happens. So we are going to see the calculation here, how this happens, how a body becomes weightless in free fall condition. You see this one, the apparent weight of freely falling object is 0 because acceleration due to gravity and acceleration of the freely falling body is equal as follows. Okay, supposing if you think for a moment, acceleration of this freely falling body, its own acceleration and acceleration due to gravity, if you think these two as separate cases, okay, then in the free fall condition these two are completely same. Okay, so acceleration of this falling body and acceleration due to gravity, if you try to understand these as separate cases for a moment, then these two are exactly same in free fall condition, right? So we will see the calculation here. Let R be the normal reaction or weight of the body. R is the weight of the body. Weight means force means ma, and force equal to W weight. Okay, here weight equal to ma. At rest condition, weight of the body is given by ma, and when this body starts moving upward, it gets heavier because gravity will be pulling it down, and this weight will be added, okay, to its own weight. That is why it is more heavy. Okay, and when the same body starts falling downward, so what happens is gravity, the force of gravity, pulling down force is greater than the weight of the body. That is why it is falling down. Gravity is winning over the weight of the body. That is why mg is written in front over here. Okay, so this is the weight due to gravity and this is the own weight of the body. Okay, now when the body is falling downward, okay, this equation gives you the measurement of the weight of the body at that condition. Supposing a body is falling freely, how do you calculate the weight of the body at this time? R is the weight of the body and mg minus ma. From here the body is falling down and the body is actually in free fall condition. Okay, now weight equal to m is common over here, g minus a, and in free fall condition acceleration due to gravity is equal to the acceleration of the freely falling body in free fall condition, right? So R equal to m, g is equal to 9.8, a is equal to 9.8 because a equal to g, right? So both are 9.8. So 9.8 minus 9.8 is 0. Okay, 0 multiplied with anything is 0. That is why weight of the body in free fall condition is 0. So this calculation gives you the weight of the body in free fall condition, and which is 0, right? So this 9.8 is on the earth, capital M, okay, mass of the earth. So this way weight of the body in free fall condition is 0. Now we are going to see the differences between free fall and weightlessness. This is also important to understand. Free fall, it occurs when acceleration of freely falling body is equal to 0. So acceleration of the freely falling body and acceleration due to gravity. This becomes equal in free fall condition. Weightlessness when g equal to 0 due to any reason. Okay, g equal to 0, then the body becomes weightless. Now free fall condition, it is the cause, and when the body is in free fall condition, it is weightless, it is the effect. Okay, free fall is the cause, weightlessness is the effect. Free fall is, it is possible in the vacuum. Vacuum means when there is no air resistance, not any kind of resistance, not even air resistance. Okay, so it is possible in the vacuum, huna sakcha possible. Okay, weightlessness, it is possible in freely falling condition. So we have seen that weightlessness is possible when body is falling freely, right? So these are the differences between free fall and weightlessness. So with this we complete this topic.